Literature review of UHI studies to find the gaps in Indian studies in comparison to international studies. Abstract: in India, most of the urban areas, especially metro cities, shows a significant amount of UHI, approximate 1-5 degrees Celsius. Although UHI is a global phenomenon, occurs almost every part of the world, but in India it is in its high potential. Despite of receiving high-grade UHI, India is not tackling problem as in priority. By reviewing both national and international literature, we find that India is far much behind from international studies in case of UHI. This paper aims to find the gaps in Indian studies in context of UHI studies. Research finds that UHI studies are in its initial stage and need to be addressed shortly by researchers and government agencies. Moreover, applied research and numerical modeling studies are almost negligible in India. So there is need of urgent steps to be taken for implementation of UHI solutions and take it on ground by means of policies and laws. Keywords: urban heat island, Indian metro cities, climate change, UHI mitigation, policies. 1. Introduction. In India, metro cities have undergone rapid urbanization, powered by the diversification of the city's economic and demographic growth. This population growth is the product of natural growth, migration, and spatial expansion across the rural hinterland. India is the country which is in under high migration rate from rural to urban areas. The main factors which are responsible for self-imposed migration are job opportunities in urban areas. City lifestyle and culture is also responsible for attracting migrants towards urban areas. Rural people hear success stories from the people of their community who move to cities. All these factors act as catalyst for excessive urbanization. Urbanization provides the creation of many serious problems such as the rise in greenhouse gases in the atmosphere, abrupt climate change and temperature increase in urban areas, resulting in urban heat island. This phenomenon acts as chain in every area. If a population of a certain area rises, the demand of infrastructure and natural resources also rises. To meet the demand of population, most of the large urban infrastructure are coming towards the hinterland of the metro cities. To be very frank, hinterland areas of metro cities are the most valuable areas for the urban scale project due to availability of population and other resources. In fact, due to population increase, demand of infrastructure reaches its peak. Because of high demand, we can resist the urban projects to come. We need to find out the sustainable ways for the urban project to come. The very first thing that comes to mind when considering sustainable solutions to cater to the issue of climate change is to reduce global warming. High temperatures are the most significant factor that is widely observed in metro cities, called urban heat island, the high temperatures in cities from their surroundings. 2. Urban heat island. Definitions. Due to urban development and human activities, the urban heat island, UHI, effect is a kind of heat accumulation phenomenon within urban areas. It is known as the urban climate's most obvious feature. The rise in ground surface temperature induced by the UHI effect would certainly affect the movement of materials and energy flow in urban ecological systems, as well as alter their structure and functions, exerting a range of ecological and environmental impacts on urban climates, urban hydrology, etc. 3 types of urban heat island. Surface urban heat island. The term surface UHI, SUHI, is used to specifically differentiate UHIs determined by land surface temperature, LST, measurements. It is observed by the use of thermal infrared data to retrieve surface temperatures on the Earth. Typically, similar relationships between the temperatures of the near-surface air and the temperatures of the ground surface have been found. Therefore, a reliable measure of an atmospheric urban heat island is the surface urban heat island. Because of variations in surface heat islands, the extent of surface urban heat islands varies with seasons. The height of the sun as well as the ground, season, and cover. As a consequence of those things, variation, the islands of surface urban heat are in the summer, usually the highest. Atmospheric urban heat island. The air of urban areas are usually warmer than the surrounding rural areas' air, which is much cooler than the air of urban area, defines atmospheric heat islands. Different cooling rates between urban areas and their surrounding rural or non-urban environments mainly result from atmospheric urban heat islands. On clear and calm nights and days when rural areas can cool more quickly than urban areas, the differential cooling rates are most pronounced. Micro-urban heat island. They refer to poorly vegetated parking lots, non-reflective roofs and concrete roads as urban hotspots. Microurban heat islands are highly influenced by microclimate conditions, so remotely sensed data is more useful for heat spot detection than atmospheric data. 4 methods used to detect UHI. Commonly UHI detection studies are carried out by 4 methods. Satellite data or remote sensing. For the UHI analysis, the variants of the Landsat satellite are mainly used to get ground surface images. Remote sensing is used to find the surface temperature of the ground, since satellites and the Earth are still in motion and it is a dangerous job to capture the shifting air temperature above the ground from the point of precision. Fixed weather station data. Another means of finding the temperature in urban and rural areas is meteorological weather station data. The basic information that are received from weather stations include sum of precipitation, 2m air temperature, maximum of 2m air temperature, minimum of 2m air temperature, downward directed solar radiation measured at Earth's surface, global radiation, duration of sunshine, total cloud cover, water vapor pressure, relative humidity, 10m mean wind speed, snow depth. Field survey. There can be 2 types of field survey: stationary survey and field survey. In stationary survey, a fixed location will be selected for temperature measurements and readings will be taken by using thermometers. Numerical modeling. According to spatial scale, models are divided into mesoscale and microscale models. 1. Numerical modeling is high computation facilities. Microscale models have generally finer grid resolution. Mesoscale models works on planetary scale with grid resolution of 100 to 200 kilometers. Numerical modeling is a system which interact independently from atmosphere, ocean, land, surface, snow, and ice. There are many models which come under the system. GCM, General Circulation Model. It is a type of climatic model which works on mathematical model which gives information about circulation of planetary atmosphere or ocean. For different energy sources, radiation, latent heat, it utilizes the Navier-Stokes equations on a rotating sphere with thermodynamic terminology. The basis for computer programs used to model the Earth's atmosphere or oceans are these equations. Along with sea ice and land surface elements, atmospheric and oceanic GCMs, AGCM and OGCM, are main components. It is a global climate model is a planetary scale mathematical model with a grid resolution of 100 to 200 kilometers and consists of fundamental fluid flow equations derived from physical laws. 1. The regional climatic models, RCMs, which are mesoscale models that focus on the climatic condition over a region or on a smaller spatial scale than GCM or a restricted area of interest, are another subcategory. The weather analysis and forecasting model, WRF, is one of the most commonly used RCMs. But using mesoscale models, the local climate processes cannot be modeled. Due to the topography of that specific region, local climatic changes occur and many RCMs are not able to account for them due to coarser spatial resolution. In such cases, microscale models with finer grid resolution can be used to perform a climate analysis over a city compared to mesoscale models. Significant growth in the production of microclimate models is occurring as the impacts of urbanization are confined to very small areas, and a very complex challenge is climate modeling on the city scale. For these purposes, researchers began using CFD, computational fluid dynamics, models to simulate the area at the city scale. CFD is a software-based platform that interconnects mathematics, physics, and computing and is commonly used by both scientific and technical fields. LE, WRF, ENVI-MET are other models which are used by group of researchers to validate their studies. But in India, numerical model research is very limited. 5. UHI mitigation in terms of urban design. The UHI mitigation definition can be translated into a multitude of distinctive intervention steps that differ in size and scale, as well as their capacity for execution and compliance with local conditions. 2. In general, mitigation initiatives use one of three action strategies: reducing the absorption of solar radiation in urban fabrics, improving airflow through the city, and effectively cooling some components in the built environment. After doing critical literature review, the main domains of UHI mitigation research domains are building envelope, landscaping, pavements, orientation. 1. Urban geometry. In comparison to the collective impact of the built environment as a whole, minimizing the singular effect of buildings on the urban microclimate depends primarily on modifications to their external envelopes. The heat consumed by structures as well as the heat they emit to their atmosphere can be decreased by these modifications. 2. Landscaping. In order to cool cities down, changing the urban environment can be used in many ways. Landscaping initiatives should not require improvements to private properties, namely buildings, or to pavement facilities. Instead, they are limited to the incorporation into the current urban fabric of new landscaping elements. 2. Shade trees. Since their canopies provide shade, trees minimize the incidence of direct solar radiation on horizontal and vertical surfaces, mainly pavements, roads, and building walls, thus reducing the heat absorbed by those components. In addition to the shading effect, when exposed to direct solar radiation, trees release vapor into the atmosphere through evapotranspiration, increasing the relative humidity and reducing the temperature of the air around them. This in turn, can contribute to a local increase in thermal comfort. Land vegetation. Extensive ground-level planting, e.g., grass lawns, can lower ambient air temperatures locally. Though vegetation-covered soil will absorb large quantities of short-wave solar radiation, it is assumed that most of the heat absorbed will be converted into vapor by evapotranspiration, as long as the soil is well irrigated, thus keeping the soil and its local climate relatively cool. However, by evapotranspiration, a decrease in soil moisture from lack of irrigation will change its daytime cooling capacity, resulting in higher near-surface temperatures. In addition, extensive use of ground vegetation can sometimes, and particularly during the night, increase the sensation of discomfort by raising the relative humidity levels in hot and humid climates, although this effect is local and depends on the particular climatic characteristics of the vegetated region. 3. Pavements. Modern paving materials, mainly concrete and asphalt, when exposed to direct solar radiation during the day, appear to absorb significant quantities of heat. During nighttime, much of this heat is emitted as long-wave, infrared radiation to the cooler street air, thereby affecting street-level thermal comfort significantly. 2. Moreover, common paving materials usually show low water permeability, restricting the absorption of water in the underlying ground layer and reducing the cooling capacity of soil surfaces by evaporation. Therefore, the key strategy for improving the negative effects of traditional pavements on the urban microclimate is to minimize heat absorption by pavements, either by altering their material properties or allowing their cooling by evaporation. 4. Orientation. The way streets are oriented and the geometrical relationship between constructed volumes and open spaces can have a significant impact on the city's thermal climate. Due to the slow nature of changes in street network and construction volumes, modifying street geometry of existing urban settings for the sake of UHI mitigation may not become a common mitigation strategy in most cities. However, modifying street geometry may become a viable strategy for generating even short-term UHI mitigation effects in urban areas experiencing rapid transformation. 2. 6. Research trends in UHI studies in India. After reviewing critically important literature studies in India, the following graph is summarized. After reviewing the results, we noted that India only works to recognize the issue and the pace of the problem. In India, numerical modeling research is very limited one. Moreover, the issue is only discussed by researchers. Basically, scientists in India work only to examine the location and reasons for the UHI. Indian UHI studies. Above table shows that research inclination of India and other countries. Above graph indicate that maximum researchers are working towards the analysis and detection of UHI, whereas in international studies are focused towards the modeling studies and policies and mitigation reviews measures. 8 Indian studies vs international studies. S.No. Indian studies. International studies. 1. Working towards detection. Working towards implementation of mitigation policies. 2. Work towards mitigation policies are negligible. Already started working towards policy reviewing. 3. No policy studies related to UHI. Implemented policies for UHI. 4. Initial stage. Already applied the mitigation measure. 5. Few are reporting and experimenting towards mitigation measures. Most of the studies are towards reviewing the performance of mitigation measures applied. 6. Descriptive research. Applied research. 7. Numerical modeling research is limited. Most of the studies are based on numerical modeling. 9 Gaps in Indian studies. We notice that UHI studies are in their initial phase in India. After review of both national and foreign research literature, we find that Indian researchers are still working to define the UHI and its speed, and some are working to find the UHI's reasons, and some of them are working towards the finding factors and in defining the relationship of factors with UHI. We find that in India, despite receiving high UHI in Indian cities, only researchers work towards the phenomenon. No stakeholders are interested or involved in tackling the issue. Also, research work is limited by the detection of UHI only. Few researchers report the mitigation steps, but there is still a lack of thorough study or experimentation of any UHI mitigation step. Ground level work is missing in India. Only researchers are working. Numerical modeling studies are very limited in India. Most of the researchers use satellite data, field survey, and weather station data for their studies. If we talk about the applied research related to UHI in India, India is far away from the destination. Researchers should therefore expand their reach of UHI research and should aim to introduce mitigation steps. 10 Conclusion. If we do year-wise comparison of UHI studies, a study was published in year 2000 aims at detection of UHI phenomenon in India. 12 In contrast to international literature, a study was published in year 1999 is talking about the predicting cooling effect of trees by numerical modeling. 47 means they are talking about mitigation measures in year 2000. In span of 20 years, Indian studies are still inclined towards the detection and potential of phenomenon. In contrast, international studies are expanding their wings and cover all aspects of UHI, including mitigation measures and policies, and building bylaws related to UHI. Moreover, they started reviewing the mitigation measures and policies as they had already implemented the mitigation measures and policies, whereas India is expanding the research area-wise. Indian researchers are only studying area impact and intensity of UHI. Not even a single research is published in India for implementation of policies of UHI and its review, because India have not crossed the initial stage of UHI research after doing research from 20 years in particular area. Indian researchers need to widen the scope of studying UHI and should start working towards the implementation of mitigation measure. As we already discussed in the paper, that Indian studies are in its initial stage of UHI and numerical studies in field of UHI is very limited. 1. After critical literature survey and comparing both national and international studies, we concluded that there is huge gaps in Indian studies of UHI. Foreign researchers already studied and implemented the policies and mitigation measures for UHI in their countries. In contrast, Indian researchers are still working on finding the potential of UHI and its impacts. India needs researchers should work on applied research for UHI. Applied research is almost negligible in India. Policy makers should also need to draw their focus towards UHI and its implementation in India to mitigate it and rising temperature in cities under UHI. Internationally, the researchers and government had already made the policies and laws to mitigate the phenomenon, but in India we are not even the path of implementation. So urgent action is needed for implementation of UHI studies as policy and laws to counteract the problem.